guys, welcome back to my YouTube channel. Today I'm going to be talking about the chain rule. So generally the formula looks something like this. So a big f of x, right, big F is equal to f of g of x. Okay, and we are trying to find a derivative of this big F, right? So capital F prime of x is going to be equal to, f, and then the prime sub in g of x, okay? So a derivative of the big function, okay? So this f here is a big function, so derivative of that. And then we have to multiply by a derivative of the smaller inside function. So g prime of x. So that is how we find the derivative using the chain rule. If we have an example that looks something like this, we're trying to find y prime, okay? Y prime. What's y prime? Well, first we look at our big function. Our big function here is basically e to the exponent of something, right? E to the exponent of something. So we have to find a derivative of e to the exponent of something. So our big function e to the exponent of some sort of variable, right? Treat this as one variable. So what is the derivative of e to the exponent of this big variable? Well, we know that the derivative of, let's say if we want to find a derivative of e to the exponent of x, right? We basically, let's treat this x as like the whole thing here, but let's think of it this way. Let's consider a simpler example. So here, the derivative of this is going to be equal to, well, of course, it's an exponential function, so the derivative is going to be itself times the ln of the base. And we know ln e, right? E is the base, but ln e is equal to 1, okay? So that makes it e to the exponent of x times 1. And that's equal to e to the exponent of x. So that's basically saying that this big function, the derivative, is going to be e to the exponent of 6x, okay? That's the big part. So we found the derivative of the big part. Now we have to find a derivative of the smaller part. So derivative of the smaller part, okay, is going to be d over dx of 6 times x. So the derivative of 6 times x, well, if you use the power rule, right, you can see this is to the exponent of 1, and you could bring this one down right here, right? So let's just copy this, e to the exponent of 6x times, and then we have to find a derivative of this, so 1 times 6 is going to be 6, right? So 6 and then x, okay? This is to the exponent of 1, and we must subtract 1 from that, okay, using power rule, and this is simply going to give e to the exponent of 6x times 6 times x to the exponent of 0, right? 1 minus 1, 0. And then we know x to the exponent of 0 is equal to 1, so e to the exponent of 6x times 6 times 1, and that's just simply going to be 6 times e to the exponent of 6x. Okay, this one we don't need to write, and then 6 times e to the exponent of 6x, like that without the brackets. And there we have it. We have found y prime. So now to find a derivative of this, we have to use a chain rule because we have functions inside of one another. To find y prime, we have to recognize our big function is sine of something, right? So what is a derivative of sine? The derivative of sine is going to be cosine, okay? So cosine, and we basically found the derivative of the bigger part, so we just have to copy whatever is inside here, so cos 2x cubed, like that, okay? So we found a derivative of the bigger part. So now we must find a derivative of the smaller part, which is basically everything inside. So it's cos 2x cubed that we need to find a derivative of. So that's going to be a derivative of this here, right? We need to multiply by it because it's just a chain rule. So basically the derivative of the big function times the derivative of the inside one. So it's going to be cos 2x cubed, that, right? The derivative of this, and now we're going to find a derivative of this. So carrying on, we just copy this, and then times the derivative of this. So derivative of cos, right? We need to find derivative of cos. This is the bigger function, okay? And then the inside is 2x cubed, okay? That's tiny, okay? That's the internal function. So the derivative of cos is going to be negative sine, right? So it's going to become negative sine, okay? Then we have to copy this part, 2x cubed, just like that. And then we also have an internal function which we need to find the derivative of. So we found the derivative of the bigger function, the outside function. Now we have to find the derivative of the inside function, which is 2x cubed. Okay, so we're going to do that in the next step. So this is equal to cos of 2x cubed times negative sine 2x cubed, and then the derivative of this, and the derivative of this we basically see we can use the power rule, okay? So we can take this 3 down, okay? So it's going to be 2 times 3x, and this is to the exponent of 3, copy the 3, subtract 1, okay? So we're finding derivative of this, okay? The very, very internal part. So we have 3 layers, you can see. First one, we found the derivative of sine, then the derivative of cos, right? And then the derivative of the inside, which we're doing now. So I'm just going to copy this. So cos of 2x cubed times negative sine 2x cubed. 2 times 3 is 6, so 6 times x squared. 3 minus 1 is 2, so squared. And then we have a negative sign right here, right? So we basically got it, but we just need to simplify. So I'm just going to write the negative sign first, make it look more simpler. And the 6x squared first, so 6x squared times this cos of 2x cubed. Okay, this part. And then times this sine of 2x cubed, like that. So I basically got this part, the negative was put in front, 6x squared was put in front, and the cos, I have this whole thing, I placed it right here. So say now we have to find a derivative of this, okay? So we are going to use the chain rule. We can see a big function, right, and a little function inside. So y prime, which is a derivative of this, is basically going to be a derivative of the outside function first. So a derivative of the outside function, we will basically use the power of a function rule. So here we take this 2 down, right? So 2, we are taking it down, 4 times 2, right? And then we have everything inside here. We're just going to copy that. X squared plus 2, right? Everything inside this bracket, copied here. And then this 2, we have to subtract 1, okay? This is called the power of a function rule. So we basically found the derivative of this outside function, okay? As shown here. And then we are going to have to multiply by the derivative, the inside function, which is everything inside the brackets. So it's going to be d over dx, x cubed minus square root of x squared plus 2, okay, using the chain rule. So 4 times 2 is going to give 8. Here it's going to be multiplied by x cubed minus square root x squared plus 2. 2 minus 1 is 1, so this is to the exponent of 1. And here, derivative of this. So we have to basically find a derivative of x cubed, right? Derivative of x cubed. Okay. And we also have to find a derivative of square root of x squared plus 2. So we also have to find a derivative of that. So minus the derivative of x squared plus 2 just like that. So here we are basically using the difference rule, so we are applying this derivative to this one and this one, right? These two which are being subtracted, derivative of the first one, first term, and the second term, just like that, okay? So the subtraction of the derivatives using difference rule. So anyways, let's continue. So here it says 8 times x cubed minus square root of x squared plus 2 to the exponent of 1. So no, we're not writing that exponent. Then here, derivative of x cubed, well, we can use the power rule. So the power rule, we basically take this 3 down. So it's going to be 3 times x, okay? And this 3 is taken down, and then we must subtract 1 from the 3. So 3 minus 1, right? Subtract 1 from this 3. And we basically use the power rule. We don't have anything really inside, it's just this x. So it's not really, we don't really need to use a chain here. But here we will need to. So here we can recognize the derivative of this, right? This is all x squared plus 2 to the exponent of a half, because square root means that this is to the exponent of a half, okay? So now we are going to have to work on this side, okay? So just copying everything else. Here this is going to be 3x squared, because 3 minus 1 is 2. And then here we have to find a derivative of this. So we must basically apply a similar rule that we did before with this 2, bringing it down, right? This half is going to be brought down, right? And we are basically using the power of a function rule. So half like this times the x squared plus 2 all to exponent of a half. And we must subtract 1 from here. 1 is the same as 2 over 2. I'm writing 2 here in the denominator just so we can easily subtract this. And then we must multiply by the derivative of the inside, which is x squared plus 2, right? This inside part. So we need to find a derivative of that inside part. So the derivative of the inside part is going to be the derivative of x squared plus 2, right? Because we found a derivative of the outside using the power of a function rule. So derivative of this now needs to be found. Okay, so next step, this is going to be equal to 8 times x cubed minus square root x squared plus 2 times 3x squared minus 1 over 2 times x squared plus 2. 1/2 minus 2 over 2 is -1/2. And here, the derivative of this, okay, this part is going to be, well, we need to find a derivative of x squared, then a derivative of 2. Derivative of x squared, right, is going to be 2x, because we use the power rule, so we take this 2 down, okay? And then this is to the exponent of 1, because 2 minus 1 gives 1, okay? Now this 2 is a constant. The derivative of a constant is going to be 0. I'm not going to write that, so plus 0. If you were to write another step, I'm not going to write that. Derivative of that is going to be 0, so I'm not writing that. So here we get this, okay? And now let's simplify it. So this is 8 times x cubed minus square root of x squared plus 2 times 3x squared minus a half. This is a negative exponent. I'm just going to put it in the denominator. So 2 times, so this is x squared plus 2 to the exponent of half times 2x. Okay, x to the exponent of 1 is x. I have this 2 and this 2 can cancel. Okay, and now from here we will get 8 times x cubed minus square root of x squared plus 2. I'm going to use round brackets in place of the square brackets. So that's going to be 3x squared minus 1 over, well, let's make this into square root because it's the exponent of half. So I'm going to write square root of x squared plus 2 and this is an x here, so times x. So instead of 1, I'm going to write x right here. So I got rid of the 1, now I'm going to write x, okay? And then this is all close bracket, and there we have it. We have found y prime, which is our derivative, right, of this original function. So this is equal to y prime, okay? And we use the chain rule. And there you can see there's a lot of different aspects where we had to apply the chain rule, where first we had to apply it here, this whole thing to exponent of 2 times 4, we had to apply it there, then we had to apply it inside the square root, right? And so you can see how we had to apply chain rule a lot into different aspects. So anyways, I hope this video helped. If so, feel free to give it a like, and furthermore, feel free to let me know what you think in the comments down below. And of course, if you are new to my channel, I encourage you to subscribe. Anyways, I hope to see you next time for another math video.